hydrogen atoms are there here? 2 only. But to balance the hydrogen atoms on both sides, left side we have, after doing the balancing of sodium atoms, left side we got here 2 plus 2, 4 hydrogens. Now to do the balancing of hydrogen atoms on both sides also, I am going to write the number as a numerical coefficient before the chemical formula of the water molecule. If I put here 2, look at here. Now 2 2s are how many number of hydrogen atoms here? 4. Okay, so 2 2s are 4 hydrogen atoms. 2 hydrogen atoms plus 2 hydrogen atoms, 4 hydrogen atoms becomes balanced on both sides. This 2 sodium atoms, again we need to compare the atom of each element on both sides. 2 sodium atoms, 2 oxygens plus 4 H2SO4. In sulfuric acid we have 4 oxygen atoms. 4 plus 2, how many oxygen atoms becomes at the reactant side total? 6. So here again at the product side also the number of oxygen atoms should be the same. 4 oxygen, Na2SO4 oxygen atoms are 4, and in water molecule 2. 4 plus 2, how many oxygen atoms now? 6. Means oxygen atoms also on both sides were balanced. Okay, still what type of atoms we have? Sodium balanced, oxygen atoms balanced, and hydrogen atoms also balanced. We have only sulfur, one atom at the left side, right side also in sodium sulfate we have one atom of the sulfur. Again we need to verify, is there any simplification of the coefficients in simple whole number ratio? There is no need of division of coefficients in simple whole number ratio, simplest whole number ratio, because here we have before the water molecule 2 and only sodium hydroxide before only 2. If we have the 4 or 6 like that before sulfuric acid, before sodium sulfate, we can able to divide with the suitable number to get the given chemical equation in simple whole number ratio. Okay, here there is no need of division of coefficients with the simplest whole number ratio. So because of that, in step 3 we need not to follow this. Again in step 4 we have to verify the given chemical equation. Verify the chemical equation. Again, how do we verify here? If we, after verifying, if we compare the atom of each element on both sides, first table and the last table, the number of atom of each element will becomes difference. Okay, so here atoms we have sodium and hydrogen, oxygen, sulfur. We have the four atoms. Now after doing the balancing of the given chemical equation, how many number of sodium atoms we got here at the left side? 2 sodium atoms. Okay, the right side also we have 2 sodium atoms. Hydrogen, 2 hydrogens plus 2 in sulfuric acid. 2 plus 2, how many hydrogen atoms becomes at left side? 4. In the same way, right side also in water molecule 2 2s are 4 hydrogen atoms. Okay. In the same way, oxygen atoms also we need to compare. 2 oxygen atoms plus in sulfuric acid, 4 oxygen atoms. 4 plus 2, 6. Right side also in sodium sulfate 4 oxygen atoms, in water molecule. This 2 belongs to 2 molecules of water. This 2 belongs to the atom of each element in the compound. Okay, this 2 not only belongs to only hydrogen atom, it also belongs to the oxygen atom in water molecule. 2 2s are 4 hydrogens, and here there is no subscript. Means what we can understand? Only one atom of oxygen. 2 1s are 2 oxygen atoms in water molecule. This 2 oxygen atoms plus in sodium sulfate 4 oxygen atoms. 4 plus 2, how many now oxygen atoms at the product side? 6. Okay, now the oxygen atoms also were balanced on both sides of the given chemical equation. Sulfur atoms are there in sulfuric acid, 1 atom, in sodium sulfate also 1 atom. So look at the table. We verified the atom of each element on both sides of the given chemical equation. The last table, if we can verify the atoms of each element on the on both sides of the given chemical equation, will get the atom of each element involved in the given chemical equation the same number. Then we can verify the given chemical equation has balanced. Okay, now this is the balanced chemical equation for the given chemical equation. Okay, first we have to check out how many number of atoms of each element involved in the given chemical equation. Then what necessary changes we need to do to balance the unbalanced atoms of element on both sides. We have to do in the step 2, and in step 3, if there is a possibility of division of coefficients to reduce the chemical equation in simplest whole number ratio, then we can do it. If it is not possible, there is no need to go for the step 3. And in step 4, we have to verify the given chemical equation again. After doing the balancing the chemical equation, we need to verify the atom of each element on both sides will become equal or not. Then we can confirm that the given chemical equation has become balanced. Okay, so this is the balanced chemical equation. So like this way, in 4 steps we need to follow for the given chemical equation. According to law of conservation of mass, mass neither be created nor be destroyed. Conserved means remains same, will not destroy. Will not destroy means whatever it may be, whatever it present already, it will not last. And whatever it there already, not create anything new for the last one. So that is mean what? Conserved. Conserved means it remains same before the chemical reaction and also after the chemical reaction. Mass of the reactants will be conserved during the chemical reaction. That's why mass of the reactants will become equal to the mass of the products. Because of that reason, based on that law of conservation of mass, we need to balance given every chemical equation. So this is the process we need to follow to do the balance the chemical equations. Okay, many number of chemical equations we have to balance here. Okay, so this is the equation: sodium hydroxide plus sulfuric acid, sodium sulfate plus water. We balanced in this way. So we have many number of chemical equations to do balance. Look at here, iron, Fe is the symbol of iron, aluminum oxide, Al2O3. Okay, when iron reacts with aluminum oxide, it produces iron oxide, Fe2O3 plus aluminum. Okay. So like this way chemical equation is given, means itself we can able to do the balance. Means in the given chemical equation we need to change, we need to do the balance, whatever it may be the number, numerical number we need to put before the formula of the compound. We need to make it in the given chemical equation. First we need to compare the atom of each element involved in the given chemical equation. Look at here, iron reacts with aluminum oxide formula what? Al2O3. So it produces, what are the products here? Iron oxide, Fe2O3 plus aluminum. Iron, how many number of atoms? Iron we have to write the spelling IRON, but the symbol of iron is not IR, because Fe, ferrum. Fe, why we have considered the symbol of iron is Fe, means already I told you, some of the symbols of elements given from their Latin names, not mostly, only few of the elements, their symbols has taken from their Latin names. Here in this same way, sodium, how do the Latin name? Natrium, that because of that sodium symbol is Na. In the same way, iron, Latin name ferrum. The Latin name of iron is what? Ferrum. In ferrum, Latin name, what are the starting letters? Fe. So because of that reason, the symbol of iron is what? Fe, capital F and small e. Fe means what element we need to understand here? Iron. Okay, reacts with aluminum oxide. Iron, here one atom of iron we have at the reactant side, and also compare the iron atoms on the product side also. Fe2 means what? It indicates 2 atoms of iron. Left side only 1 atom of iron we have, but right side we have how many atoms of iron? 2. So we need to balance the iron atoms on both sides. In the same way, aluminum Al2O3 in aluminum oxide, Al means aluminum. The symbol of aluminum is A, capital A, small l, Al. Al2 means it indicates 2 atoms of aluminum. In aluminum oxide, now number of atoms of aluminum, how many are there here? 2. At the right side, at the product side, Al we have written here. Only it indicates 1 atom of aluminum. Left side 2 atoms we have, but right side we have only 1 atom. Means what? We need to balance the aluminum atoms also. Okay. Next, what type of element is present in the given chemical equation? 3 oxygen. 3 atoms of oxygen present. Here only 3 elements are involved in this given chemical equation. Iron, aluminum and oxygen. Iron atoms also unbalanced both sides. Aluminum also unbalanced. In the same way we will compare oxygen. In aluminum oxide, oxygen, how many number of oxygen atoms? 3 oxygen atoms. Right side also we have 3 oxygen atoms. Oxygen atoms are balanced on both sides of the given chemical equation. So we need to do the balance of atoms of iron and atoms of aluminum. Look at here, iron we have right side 2. So to balance the iron atoms, I am writing the number 2 before the symbol of iron. Okay. So now the iron atoms balanced or not? Left side 2 iron atoms and right side in iron oxide we have 2 iron atoms. Okay. But here aluminum you can compare here. 2 atoms of aluminum we have at the left side, but right side we have only 1 aluminum atom. Al2 we need not to write here. Okay, this is the wrong way. Aluminum only 1 atom means it indicates Al. 2 atoms we need to balance. Left side we have 2 aluminum atoms. Because of that we can write the number 2 at the product side before the symbol of aluminum. So now we have to check atom of each element on both sides of the given chemical equation. Iron atoms, how many are there here after balancing? 2 iron atoms and also right side 2 iron atoms. Okay, so simply we can write the table and we'll verify at last step element and LHS and RHS. What are the elements we have? Iron, aluminum, oxygen. Symbols I am writing only. Okay, iron we have after balancing. I am verifying the given chemical equation after balancing. Iron atoms left side 2 we have and also right side 2. Aluminum left side 2. Right side I put the number before the symbol of aluminum to balance the aluminum atom. Oxygen 3 we have. Right side also 3. So like this way we have to verify after making the necessary changes or after keeping the necessary coefficients before the symbol of the element or before the formula of the compound. We have to verify. If we can verify in this way, we need not to do any mistake. Okay. At last, after completing the balancing the given chemical equation, we need to verify in this way and we have to check the given equation has become balanced. Okay. So this is the chemical equation. Iron plus aluminum oxide gives rise to iron oxide plus aluminum. Okay. Iron and aluminum atoms also we balanced. So in this way we have to balance the given chemical equation itself with 4 steps. Every time we need not to follow 4 steps. Step 1, step 2. Step 1, if they can given skeletal equation, we have to write the word equation. If they can give, we can write the skeletal equation first by using the proper formulas of the compounds and by using the symbols of the elements, proper symbols of the elements and proper formulas of the compounds, we have to write the skeletal equation. Unbalanced chemical equation first we can write by looking the word equation. Then we have to compare atom of each element, how many number are involved on both sides of the given chemical equation. We have to compare. Then we have to do the necessary changes. Okay, which atoms were unbalanced on both sides. So like the way in a process wise, in a proper way, if we can follow, then we can do the given chemical equation in easy and simple way. Okay, in the same way we can also look at one more. Mercury HgNO3 taken to mercuric nitrate. Mercuric nitrate, its formula is HgNO3 taken to plus potassium iodide. Potassium iodide gives rise to mercuric iodide plus potassium nitrate HgI2 plus KNO3. Okay, potassium nitrate. In this given chemical equation, mercuric nitrate and potassium iodide are the reactants. Hg is the symbol of mercury. Mercury, the name of the element, is starting with M, but we have not written here mercury, the symbol not M. Okay, because the symbol of the mercury element came from its Latin name, so that's why hydroxerum. Okay, the Latin name of the mercury is what? Hydroxerum. So that's why the symbol of hydroxerum is also starts with hydroxerum, Hy. The first letter is H and the next letter is Y. But here if you observe, mercury, the symbol is not Hy and it's not only H. H already we have given for the symbol of element hydrogen. So that's why the next coming element start with same letter, then we can go for the second letter, or some of the times the second letter we cannot consider according to the pronunciation on which letter we have making stress while pronouncing the symbol of the element, whatever it may be, from its Latin name or the general name of the given element, where we are making the stress while pronouncing. The stress letter also considered as the second letter of the symbol of that element. Okay, here hydroxerum Hy, but here if you observe the hydroxerum symbol is Hg. Okay, hydroxerum, here we are giving the stress. That's why the symbol of mercury is Hg. HgNO3 taken to mercuric nitrate. This reacts with which one? Potassium iodide. Potassium is also we have written here K. Look at here, potassium, POTASSIUM, potassium. P starts with, but its Latin name is kalium, KALIUM, kalium. That's why potassium symbol is what? K. Latin name kalium, potassium symbol, potassium element, Latin name kalium. The symbol of potassium is K. Potassium iodide, the compound potassium iodide Ki. It gives rise to mercuric iodide and also potassium nitrate. So what are the elements? How many number of elements are involved in this given chemical equation? Once we can look at mercury and nitrogen, oxygen, potassium, iodine. These are the different elements are involved in the given chemical equation, and atoms of each element we need to compare on both sides whether they have balanced or not. Look at here, if we can look at hydrogen, so here NO3, why do we written in the bracket, and here 2 taken 2, HgNO3 taken 2 we can read, or mercuric nitrate also we can read. Taken 2 means here this is the group of atom of ion NO3 minus. That's why the group of atom we have to keep it in the bracket, and we can write its valency after the bracket, mercury valency. That is why we have written NO3 in bracket. So this 2 belongs to for this group of atom of ion NO3. 2 atoms of nitrogen, 2 3s are 6 atoms of oxygen. But here mercury only we have, there is no subscript appearing here. Because of that reason, how many number of atoms of mercury here? Only 1 atom of mercury. Right side also compare the atom of mercury here. How many we have? Mercuric iodide. There is no subscript we are observing here. Means how many atoms of mercury? 1. Atoms of mercury on both sides, only 1 atom we have. And nitrogen atoms, 2 nitrogen atoms at the left side, at the reactant side. In potassium nitrate we have only 1 nitrogen. Nitrogen atoms are not balanced, we need to balance. Oxygen atoms are present at the reactant side, 3 2s are 6 or 2 3s are 6. Here only 3 we have at the product side, 3. Okay, means oxygen atoms also we have to do balance. Potassium iodide, potassium 1 atom, iodine 1 atom. Here in potassium nitrate 1 atom of potassium we have, but in mercuric iodide 2 atoms of iodine we have. Iodine atoms not balanced, only potassium atoms balanced. So here if we can look at here, oxygen atoms, look at here, 3 2s are 6 oxygen atoms we have at the reactant side. Here how many we have? Only potassium nitrate 3. If I put number 2 here, number 2 here, now 3 2s are 6 oxygen atoms becomes. 3 2s are 6 oxygen atoms becomes balanced. And also here This 2 means it indicates 2 molecules of potassium nitrate, 2 atoms of potassium, 2 atoms of nitrogen, 2 3 so 6 atoms of oxygen, 2 atoms of potassium. But here left side if we can observe, only 1 atom of potassium we have. To balance the potassium, I am writing here number 2. Look at here, 2 atom of potassium, 2 atoms of potassium. In mercuric iodide, I2 means 2 atoms of iron, 2 atoms of iodine. So here 2Ki, potassium iodide means 2 atoms of potassium, 2 atoms of iodine. 2 atoms of potassium, 2 atoms of potassium balanced, 2 atoms of iodine, 2 atoms of iodine balanced, 1 atom of mercury, 1 atom of mercury balanced, and also NO3 taken 2 means this 2 belongs to atom of each element in the group of atom NO3, and nitrogen atoms also 2, oxygen atoms 2 3s are 6, nitrogen atoms 2 we have, and right side also I put already 2 before potassium nitrate, so that's why here nitrogen atoms also were become balanced, 2 nitrogens, 2 potassium, okay, 2 3s are 6 oxygens, 2 3s are 6 oxygens. Once we have to verify the atom of each element on both sides whether they become balanced or not. Element left hand side and right hand side. What are the elements we involved here? I am going to write the symbols: mercury Hg, and also nitrogen, oxygen, potassium, iodine. After balancing, how many number of atoms of mercury we have on both sides? At left side 1 atom of mercury, and also at the right side here there is no number, no numerical coefficient we have written before mercuric iodide. Because of that, how many number of mercury atoms? Only 1 here, there is no subscript, so that's why 1 atom of mercury. Nitrogen, left side nitrogen atoms HgNO3 taken 2 means nitrogen atoms are 2 left side. Nitrogen atoms at left side, at the reactant side we have 2. In the same way right side also we have written the number, numerical number 2 before potassium nitrate to balance the oxygen atoms. So at the same time nitrogen atoms also becomes balanced. So right side also we have 2 KNO3 means 2 atoms of potassium, 2 atoms of nitrogen, 2 3s are 6 atoms of oxygen. So 2 nitrogen atoms. Oxygen, left side how many number of oxygen atoms we have? 3 2s are 6. Right side also 2 molecules of potassium nitrate, 2 3s are 6 oxygen atoms. Potassium, to balance the iodine atoms I have written the number 2 here. So potassium or atoms at left side 2. In the same way mercuric iodide also we have the number of atoms of iodine 2. Sorry, potassium we are comparing. Left side potassium 2 atoms are there, right side in potassium nitrate 2 we have written before the KNO3, so 2 atoms of potassium. Right side also the atom of potassium we have 2. Iodine, left side how many we have before potassium iodide? We have the number 2 means it indicates 2 atoms of potassium, 2 atoms of iodine. So iodine left side also we have number of atoms 2. Right side also HgI2 mercuric iodide also have 2 number of atoms of iodine. So if we look at the table, atom of each element on both sides we have the same number, then we can confirm the given equation has become balanced. So like this way we have to verify once after making the necessary changes, after writing the necessary numerical numbers before every given formula of the given chemical compound. So we have to verify at last, then we can able to confirm the given chemical equation has become balanced. Okay, this is the way of doing the balancing the chemical equation. We have more number of chemical equations in this lesson. So in easiest way and a simple way we can able to do the balancing the chemical equations. Okay, potassium chlorate KClO3. Potassium chlorate only one compound here. It gives rise to, after going into chemical change, it gives rise to potassium chloride plus water, sorry, oxygen O2. Look at here, here we have only one reactant undergoes into chemical change and it decomposed into 2 products. This type of chemical change or chemical reaction we can also say to as a decomposition reaction. Mainly these chemical decomposition. decomposition reactions or takes place in the presence of heat or in the presence of light or in the presence of electricity. Okay, in the presence of a catalyst, sometimes in the presence of catalyst means like sunlight, so like in the presence of anything like heat means we can represent delta over the arrow mark, above the arrow mark, in the presence of a temperature, when we increase the temperature of the reactant or we can maintain certain pressure of the substances, reactants during the chemical process, then these decomposition reactions takes place. So such heat, light, electricity, and how much amount of temperature we are maintaining to complete that chemical decomposition, and how much amount of pressure we have to maintain. That amount of pressure, 1 atmosphere or 2 atmosphere, that pressure and temperature, everything we can able to shows while writing the chemical equation above the arrow or below the arrow. Okay, whatever the catalyst we are using here. What do you mean by the catalyst here? The catalyst is a substance that actually it do not participate in the chemical reaction, but it useful to increase the rate of chemical reaction, or it is useful to decrease the rate of chemical reaction, but it will not participate in the given chemical equation. Such substance we can call as your catalyst. So whatever the catalyst we are using, for example nickel, most of the chemical reactions undergoes in the presence of oxidation reactions, mainly nickel catalyst, nickel, copper, platinum, such type of catalysts, phosphorus pentoxide, P2O5, so such type of catalysts, if any useful, that also we have to write above the arrow mark or below the arrow mark. Okay, delta means it represents in the presence of heat. So here only one reactant we are observing. Up to now we observed reactants 2 or more, products also 2 or more or 1. Here one reactant decomposed into 2 or more products means that chemical reaction we can say to as chemical decomposition. Okay, 2 reactants combined and it produces only one single product means that is the chemical reaction we can say to as chemical combination. The 2 reactants combined together and they produce only single product, so that chemical change we can say to as a chemical combination. So sometimes these types of chemical changes, chemical combination, chemical decomposition, chemical displacement, chemical double displacement, these types of chemical changes actually belongs to lower class, but sometimes they may also ask, they have to give the chemical equation and they will ask us to identify the given chemical equation is what kind of chemical change, whether it is chemical combination or decomposition or displacement or double displacement. Okay, by looking the chemical equation we can able to understand clearly what type of chemical change has taken place in the given chemical equation by observing the number of reactants and number of products. Only one reactant we have in the given chemical equation and 2 products we have means it is decomposing. Only single reactant is decomposing into 2 or more products. So such chemical change we can say to as a chemical decomposition. Only one product we are observing in a chemical reaction, in given chemical reaction, only one product we are observing means what we can understand there, 2 reactants are present at the left side of the given chemical equation. Only one product, for example here hydrogen plus oxygen gives rise to water. We have only one product right side, but left side how many reactants we have? Hydrogen and oxygen. These 2 are combined, plus we have written, look at here, these 2 combined together and produce only single product. This is chemical combination. Chemical combination type of chemical change. So this one is chemical decomposition. So like this way we have 4 kinds of chemical changes: decomposition, combination, displacement, double displacement. While writing the chemical equations again I will explain what is the displacement and double displacement. Look at here, potassium chlorate gives rise to potassium chloride plus oxygen. We need to compare the atom of each element involved in the given chemical equation on both sides of the chemical equation. Potassium chlorate, 1 atom of potassium, here no subscript, chlorine is the symbol of chlorine, Cl, okay, 1 atom of chlorine. Oxygen atoms how many are present here? 3. O3 means this 3 belongs to only oxygen, this 3 not belongs to chlorine and potassium. if we have written the numerical number before the compound formula of the compound, then that number belongs to atom of each element in the given compound. But O3, O2 we are writing means that number belongs to only that particular atom. Okay, here only 3 atoms of oxygen, 1 atom of chlorine, 1 atom of potassium. And right side also potassium, 1 atom, chlorine 1 atom. Here potassium and chlorine atoms were balanced on both sides. But which is unbalanced here? Atoms of oxygen. Left side if we have, we can look at the left side in potassium chlorate, 3 atoms of oxygen we have. Right side we have 2 atoms of oxygen. So to do balancing of atoms of oxygen on both sides, what change we need to do here? Look at, if we can look at oxygen, O2 we have here 2. Here if we look at in potassium chlorate, O3. If I will write 3 before O2 and if I will write 2 before potassium chlorate, now the oxygen atoms becomes balanced because 2 3s are 6 oxygen atoms. Look at here, 2 3s are 6 oxygen atoms, and here 3 2s are also 6 oxygen atoms. Oxygen atoms were balanced. But again we need to check the remaining atom of elements involved in the given chemical equation on both sides. 2 potassium atoms, 2 chlorine atoms. But here at the right side we have only potassium chloride, 1 molecule of compound only, 1 atom of potassium, 1 atom of chlorine. So to balance potassium and chlorine atoms, what I am going to doing here, I am writing the numerical number 2 before potassium chloride. So now the potassium atoms and the chlorine atoms are also balanced on both sides. Look at here, 2 potassium atoms, and here also right side potassium chloride, before I have written 2 number, means 2 potassium atoms, 2 chlorine atoms and 2 chlorine atoms. Look at here, what are the elements involved in this given chemical equation? We can verify after doing the balancing. We have to verify on both sides whether atom of each element on both sides will become equal or not. Okay, potassium, what are the elements involved in this given chemical equation? Potassium, chlorine and oxygen. Okay, potassium left side how many atoms? 2. Right side also becomes 2. Chlorine atoms, this 2 belongs to atom of each element in the given compound. 2 potassium atoms, 2 chlorine atoms, 2 3s are 6 oxygen atoms. Okay, now chlorine atoms also left side 2, right side 2 chlorines, 2 potassium atoms, 2 chlorine atoms. Oxygen atoms in potassium chlorate how many we have? 2 3s are 6. Right side also 3 2s are 6. If you look at the table, atom of each element on both sides becomes equal in number or not? Means what it indicates? The given chemical equation has become balanced. Okay, potassium chlorate gives rise to potassium chloride plus oxygen. Look at here, we can go for another chemical equation. Oxidation of carbon compound here, C3H8 is the name of the compound, is propane. Okay, propane. Combustion reaction means it combusts in the presence of oxygen. If oxygen is not present, we are unable to burn any object. Okay, means which gas is supporting for the combustion? Oxygen helps for combustion. Okay, this carbon compound also burns in the presence of oxygen. So that's why oxygen is going to add. Because of that reason also we can say this type of reactions are oxidation reactions. So here the carbon compounds undergoes in chemical reactions, they also undergoes in oxidation reactions. So here burning of propane, we have burning of propane, balancing chemical equation in our chemical equations lesson. Okay, oxygen. So they produce mainly when carbon compounds undergoes in oxidation reaction or burns in the presence of oxygen, they release, when they are burning, they release which gas? Carbon dioxide gas. When they combust, they release carbon dioxide gas and also liberates water molecules. Okay, so here this is the oxidation reaction of propane. C3H8 is the formula of propane. It burns in the presence of oxygen O2 and also produces carbon dioxide plus water. Okay, look at here. Carbon atoms, how many are there in the left side in propane? 3 atoms of carbon. But in right side we have only 1 atom of carbon. Okay, and hydrogen atoms In propane we have H8. This is the carbon compound C3H8. Why we are writing the formula of C3H8 means according to the general formula of alkanes, alkynes, we have CnH2n plus 2. Because of that reason the number of hydrogens we will get 8 here based on the number of carbon in the compound. We will get the number of hydrogens. Okay, in carbon and its compounds we can learn clearly these compounds. How do we write the compound formula? Okay, here propane formula we have to remember C3H8. So now hydrogen atoms, how many are there in propane? 8 hydrogens. Right side in water molecule only we have 2 hydrogens, and oxygen left side at the reactant side only 2. O2 means 2 atoms of oxygen. Right side we have in carbon dioxide 2 atoms of oxygen, and in water molecule H2O, O means here 1 atom of oxygen. 2 plus 1, how many atoms of oxygen? Right side 3, but left side we have only 2 unbalanced oxygen atoms. Okay, so now oxygen atoms, hydrogen atoms and carbon atoms, all atoms of each element on both sides we need to do balance. So first look at here, carbon atoms are 3 left side. If I will put 3 here, the carbon atoms becomes balanced. But again we need to compare the remaining atom of elements. Carbon atoms balanced if I put 3 before the carbon dioxide. Now oxygen atoms becomes how many? 3 2s are 6. Plus in water molecule 1 atom there. 3 2s are 6 plus 1, 7 it becomes. But here hydrogen atoms how many in propane? 8. But here in water molecule 2. If I will put 4, 4 2s are 8. Hydrogen atoms also balanced on both sides. Now we have to compare the oxygen atoms. 3 2s are 6 in carbon dioxide oxygen atoms, plus 4 molecules of water means 4 2s are 8. Hydrogen atoms 4 atoms of oxygen. 3 2s are 6 plus 4 oxygen atoms. Total how many oxygen atoms on right side? 10 oxygen atoms. So now here to balance the oxygen atoms, left side we have O2. So left side also we have to balance the oxygen atoms. So what number I am writing here? 5 before the O2 molecule. Now 5 2s are 10 oxygen atoms left side, and 3 2s are 6 oxygen atoms plus 4 oxygen atoms, 10 oxygen atoms at the right side also. So once we have to verify the given chemical equation we have balanced or not, and atom of each element becomes balanced or not. Okay, while verifying this table we can confirm the given chemical equation has become balanced. What are the elements involved here? Carbon, hydrogen and oxygen. Carbon left side we have 3 atoms, right side also we got 3 atoms, hydrogens 8, and also right side 4 2s are 8, oxygen 5 2s are 10. In this propane we do not have any oxygen atoms, only oxygen atoms 10. Right side 3 2s are 6 plus 4 10. Look at the table, atom of each element becomes equal on both sides, left hand side and right hand side. Now we can say to as the given chemical equation has become balanced. So these are the changes we made, okay, to balance the given chemical equation. Combustion of propane. Just this chemical equation, they don't give the chemical equation, just they can give the write the chemical equation for combustion of propane and also balance the given chemical equation they will ask. Means we have to write this chemical equation by using the formula of propane. Combustion means with which gas, in the presence of which gas it combusts? Oxygen. When the carbon compound or any one it is going to combust means it releases which gas? Carbon dioxide and water molecules. We have to remember this equation and we can go further to the balancing the chemical equation. Okay, so if by using the formulas, if they not given, just they can give the word equation, zinc plus silver nitrate. If they will give like this, we have to write proper symbols of the element and also proper formula of the chemical compound. Okay, gives rise to zinc nitrate, plus silver. Look at here, zinc. What is the symbol of zinc here? Zn. Silver, Latin name of the silver element is argentum. So the symbol of silver AgNO3. AgNO3 is the formula of which one? Silver nitrate. Zinc nitrate ZnNO3 taken 2. Silver again Ag. If the equation they can give like this also, means in word equation. They will ask us to write the chemical equation for the given word equation and also balance the chemical equation. So that's why we have to write proper symbols of the elements and also formula of the compound correctly. First unbalanced chemical equation we have to write. Then we have to compare the atom of each element involved in the given chemical equation on both sides. Then we have to try to do the balancing the chemical equation. Okay, look at here. Zinc, one atom of zinc and one atom of zinc, right side also. So zinc atoms were balanced. Silver nitrate AgNO3, Ag one atom, nitrogen one atom, oxygen atoms were present 3. Silver and also silver atoms were balanced. But NO3, here nitrogen atoms 2, oxygen atoms 6. Here nitrogen atom only 1, oxygen atoms 3 we have. So to balance the oxygen atoms, 3 to the 6 we have. Here we have already 3. If I will write number 2 here, look at here, 2 3 is oxygen atoms also becomes 6. And 2 nitrogens, 2 silver atoms becomes left side. Because of that, I am going to write the number 2 before zinc nitrate. So now the atom of silver, atom of silver atoms becomes 2 here, but if we compare right side only one atom of silver we have. If I will write number 2 here, the silver atoms also becomes balanced. So 3 to the 6 oxygen atoms becomes left side. Here 3 to the 6 oxygen atoms we have already. Nitrogen atoms how many we have? 2 nitrogen atoms. Here nitrogen atoms 2. And silver atoms 2 we balanced. Zinc we have one atom, zinc we have one atom. Look at here. If we make only change before silver nitrate and the silver atom, just the equation becomes balanced. So now what are the elements involved in the given chemical equation? Look at here. Once we have to verify itself the chemical equation, if we are going to balance also, at last we need to verify in this way, we can confirm our given chemical equation becomes correct. Okay, zinc and silver, nitrogen, oxygen. Look at here, zinc one atom we have, right side also one atom, silver 2 atoms left side, right side also 2 we have, nitrogen 2 atoms of nitrogen, and NO3 taken 2 means 2 atoms of nitrogen, 2 3 is 6 atoms of oxygen. So right side also nitrogen atoms we have 2, oxygen atoms 2 3 is 6, right side also 3 2 is 6. If you look at the table, we have the number of each element on both sides becomes equal. Okay, means what we can confirm here, the given chemical equation we have balanced. Okay, so this is the balanced chemical equation. If they will give the word equation like this, first we have to write unbalanced chemical equation, that is skeletal equation, proper symbol of element and proper formula of the chemical compound we can write, and we'll compare the atom of each element on both sides, and we need to make a necessary changes to do the balancing of a atom of each element on both sides. Okay, this is the equation we have to balance in this way. We have like this chemical equations, many number of chemical equations we have. So still some chemical equations, how to do balance, tomorrow we'll discuss. Thank you.